Bismillahirrahmanirrahim. Assalamu alaikum dear students. In today's lecture we are going to talk about the electronegativity and the factors affecting the electronegativity. Basically, electronegativity is a tendency or the ability of an atom to attract the shared pair of electron that is present in a bond. If we take the example of the HCl, so the bond between H and Cl is containing two electrons. So both of these electrons are shared by Cl as well as the H. So which of these attracts more would be the more electronegative atom, and the atom that attracts the least would be the less electronegative element of these molecules. Basically, electronegativity is the ability of an atom to attract the shared pair of electron between two atoms. The most important thing about the electronegativity is that it is not an inherent property of an atom or an element, but it's the property of an atom within a molecule. So you can say that an isolated atom has no electronegativity because as long as it's not bonded to an other atom, it cannot have a shared pair of electron, and how it's possible to attract that electron pair. The next are the factors affecting the electronegativity, and that are very much important as the electronegativity topic is concerned. So first of all, the first factor that is responsible for controlling the electronegativity is the size of atom. The greater the size of atom, the lesser would be the value of the Z effective. So you can say that the size is connected with the Z effective value, and Z effective value has a direct influence on the value of the electronegativity. Greater the Z effective, greater would be the value of the electronegativity. So smaller atoms have greater value of Z effective and smaller atoms have greater electronegativity. You can say that the fluorine is the most electronegative element of the periodic table because the fluorine is having very small size. So Z effective for fluorine is very much high. So that's why the electronegativity of the fluorine is greater, or you can say the greatest of all the elements that are present in the periodic table. The next factor is the oxidation number of the atom. That's oxidation number has a direct influence on the value of the electronegativity. So first of all, as you people know that oxidation number can be a positive value, it can be a negative value. So first of all, we will talk about the positive oxidation number. Here is that M plus 3 has greatest electronegativity as compared to that of M2, and that is having greater electronegativity as compared to the M plus. So here is M plus. So greater the positive oxidation state, greater would be the electronegativity of an atom. What is the trend if we talk about the negative oxidation state? So whenever an atom is converted into the anion, the value of Z effective falls. So greater the negative value of the oxidation state, smaller would be the electronegativity. So you can say that if we have Cl and Cl minus, so which of these would be more electronegative? So you can say that chlorine would be having higher electronegativity as compared to that of the chloride. Why? Because the chloride ion is having smaller Z effective value than the chlorine. The next point is number of intervening orbitals. What is meaning of the intervening orbitals? Basically, intervening orbitals are the inner orbitals or the inner shells next to the valence shell. Greater the number of intervening orbitals, smaller would be the value of the electronegativity, because greater intervening orbitals and greater intervening electron lead to the smaller values of the Z effective. So if we look at the halogens from fluorine, chlorine, bromine, iodine and astatine, fluorine is having greatest electronegativity and astatine is having the smallest electronegativity in this group. Why does this is happening? Because fluorine is having smallest number of the intervening electrons or intervening orbitals, whereas the astatine is having the greatest number of the intervening orbitals. So the electronegativity of the astatine would be smallest of all the elements present in the halogens. Next factor is the nature of the bonded atom. As we explained earlier that electronegativity is not an inherent property of the atom or element. So other atoms present in the molecule affect the value of the electronegativity of an atom of particular element. So if we talk about the accepted value of the electronegativity for phosphorus, that is 2.15. That is the accepted or the literature value of the electronegativity of the phosphorus. But if we talk about the particular molecules, phosphorus is connected to 3 Cl atom. The electronegativity of phosphorus in this molecule is 2.24. And if the phosphorus is connected to 3 fluorine atom, the electronegativity of the phosphorus is 2.44. So you can look that electronegativity of phosphorus is changing in each and every molecule. So why the electronegativity of the phosphorus is different in PCl3 and why it is different in the PF3? Because phosphorus is same. What's changing? The bonded or the linked atoms are changing in the molecule. So the electronegativity value is also changing. Higher the electronegativity value of the bonded atom or the linked atom, greater would be the electronegativity of the central atom. Next point is ionization energy and the electron affinity values. According to the Mulliken's scale of electronegativity, the value of electronegativity of an element or an atom is directly dependent upon the values of the IE and EA. So greater the value of ionization energy, greater the value of electron affinity, greater would be the value of the electronegativity for a particular element. So halogens are having greater values of the ionization energies and the greater values of the electron affinities. So that's why halogens are having highest values of the electronegativity in the periodic table. The next and the last most important factor that is related to the value of the electronegativity is the type of hybridization. Basically, different hybrid orbitals are having different S character within them. If we talk about the organic molecules, the state of hybridization changes from sp3, sp2, sp. So different hybrid orbitals are having different S character, and greater the S character of hybrid orbital, greater would be the electronegativity of the central atom. If we talk about the different types of the hybrid orbitals, sp3, sp2, sp, the S character is not same in all these molecules. In the sp3, it's 25%. In the sp2, it's 33.3%, and in sp, it's 50%. So, if we talk about the electronegativity of the carbon in these 3 molecules, so that's not same in these 3. In the CH4, the central atom is sp3 hybridized. In the CH2 double bond CH2, the central atom, or you can say the carbon atoms, are sp2 hybridized, and in the CH triple bond CH, the carbon atoms are sp hybridized. So electronegativity value of the carbon would be greatest in the triply bonded molecule, then followed by the doubly bonded molecule, and the last is the methane. Methane is having carbon atom in the sp3 hybridization. So greater the value of S character, greater would be the electronegativity. So this was all about the electronegativity and the factors affecting the value of electronegativity. If you have any question, you can post your question in the comment section. We will meet in the next video. Up till then, Allah Hafiz.